Everybody, and welcome to Cranky Calculus. We're going to talk about volume and how to find it using the washer method, which again is just it pertains very similar to the disk method, is when we rotate a object around an axis. And I do real quickly want to show you what that looks like. Object right here where you just pretend this area right here is filled in where I have the mouse. And what we're going to do is we're going to rotate that around the red axis here, and it's going to form a washer. Now the difference between a washer and a disk is a disk sits entirely on the axis of rotation. As you can clearly see from a problem like this, which is going to result in the washer, there is space between this purple part of this function and then the red axis in which we're rotating around. So I'll real quickly show you what that looks like. So I'm going to take this into a 3D. You're going to see this get rotated around, a little slower than I want it to be, around this whole, there we go. There's the whole thing. So there's us rotating that shape around, and that is going to form that solid right there that is made from us rotating that one piece all the way around. So you can kind of get a visual. This washer happens to have a hole that goes right through the middle. All the washers don't have to have a hole that goes all the way through. As long as any section of those, there's any open space as we rotate it, it's going to become a washer. Now that you can visualize what these washers look like, let's go ahead and give you the formulas here. So rotating about a horizontal axis. So to get this formula, we actually are taking, with a washer, we're rotating two different figures. And then what we're going to do is we're going to take the larger figure, that larger volume, and we're going to subtract out the smaller volume. So this is going to be the integral from a to b of pi big R of x, and that big R of x, by the way, is a squared, minus pi little r of x squared dx. So we're going to do what we did for a disk, is we're going to find two different disk method volumes and subtract them. We just put them into one integral. When I do start doing these problems, I will take out the GCF of just the pi, and I actually put that in front of the integral. When we do this around a vertical axis, we have to use different values. So we're going to go from C to D, because C and D are going to be y values, and then pi r of y all squared minus pi r of y squared dy. And that's going to give us our washer, which again you can see is right there. And let's go ahead and do some problems. For our first example here, we are going to find the volume of a solid formed by revolving the region bounded by the graphs of the given equations about the indicated axis. So we're going to have the graph of 4 minus x squared. We did this in our disk video, but this time I'm going to rotate about the line y equals -2 so that you can kind of see similarities and the differences of this. So we're just looking for when x is going to be positive here. So the graph is going to look like this. There we go. And I'm actually going to shade in this region right here so it's a little bit easier to see what's going on here. And then we're going to do this about y equals -2. And I'm going to draw my little rotation right there so you can kind of see what's going on. All right, if we were to rotate this, it kind of looks like, I don't know, the top of a bagel. If you were to cut it before you put the cream cheese on, take it apart, top part. That's what I think it looks like when you are to rotate this thing. So what we're going to do here is we always draw from our axis of rotation, and so we're going to have two radii. We're going to go to the top of the object, and then we're going to go to the bottom of the object. So for the first radii, we're going to go to the very top of the object. Always start from the axis of rotation, and just kind of bold that a little bit so you can see it. So for this, I'm going to have a big radii, so big R of x is going to be, it's always big minus little. That is huge here. You're going to hear me say that a lot in this video. It is big minus little. In this case, big is the top. The top part of that shape is going to be that 4 minus x squared minus the little. The little is actually the very bottom right here, which is axis of rotation, because that's where my green partition sits. So it's going to be minus -2. That usually confuses people, so they'll just be like, oh, about 4 minus x squared plus 2. Same thing. Okay? And now I'm going to do the same thing, but now for my little r. So I'm going to have this. When I rotate this, it'll be a full solid. It'll have like this flat part right towards the middle. Now I need to take away that flat part, which is going to be this radius. Again, start from the axis of rotation. I'll just darken it in a little bit, and I'm going to take out the orange section. This would give me that empty space that we have for our object. So this r of x is equal to big minus little. The big on the orange I just drew is 0, minus the little is going to be the bottom, which is x is the rotation, which is -2, which is very clearly 2. And then what we're going to do here is we're going to find this volume. I said before, I'm going to take what we had up here, and I'm just going to pull out the GCF of the pi for each of those. So I'm going to pull the pi out in front, integrating from 0 to 2, because from left to right, we go from 0 to 2. I did this in the disk video as well. And we're going to get 4 minus x squared plus 2, all squared. And that's going to be the big radius being squared minus the little radius squared, which is just 2 squared. And we're going to do dx to that. So you're going to take out your handy dandy calculator. I have already done this. I'm a little bit ahead. And I got an answer of 120.637 units cubed. I'm going to omit that because we don't expect you to do that on the calc exams. So there you go. That is your first problem with rotating using washers. Okay, so for this next problem here, it's going to be the exact same prompt. So we're still going to be using the same graphs. So I'm going to go ahead and sketch those real quick. So same graphs. And I'm going to draw the exact same shape, except this time we are going to rotate it at a different axis. In this case, it's going to be a vertical axis. I'm going to shade that in real quick. And our vertical axis we have here is x equals -3. Okay? So for the first problem that we did, we had the axis below. Okay, you can use the same techniques in case the axis is above. This axis is to the left, and this same technique I'm going to use is going to be in case that axis is to the right. And actually the problem on the bottom, I forgot if it's in above or to the right one, but the problem on the bottom here will be something similar to that. So we're going to rotate this around there. So that's going to make a volcano shape, kind of. Pretty big empty hole there in that volcano. But volcano shape is what's coming up. I'm going to draw my axis, or my big radius right here, always for my axis of rotation. So I start there, and I'm going to end when I get to the other side of the object. I'm going to darken that up a little bit. So there's my rotation. Okay. Real quick, just so I can get this in x equals terms. This is x equals square root of 4 minus y. I did this in my last video, so you can check it out there. So now I have that as my x equals my big R of y. We're in terms of y here because using the washer method, we're going to be rotating around a vertical axis, which produces dy's. We need terms in y. This is going to be the big, in this case, big minus little, since we're going looking at bigs left and right. Big is to the right. Think of a number line. The numbers on the right of the number line are bigger. Big minus little is going to give us the square root 4 minus y minus the axis of rotation, which is -3. So you can think of it this way. It's the square root of 4 minus y plus 3. And then for little, start on the axis of rotation and stop and hit the bottom of the object, which is right here. And that is going to be r of y, which we're going to start from right minus left here because it's always big minus little. 0 minus -3, which gives us a 3. So if I were to find this volume, I'm going to get pi integral from 0 all the way to 4. Again, I did this in my last video. We're integrating the bottom from 0, and the top part is going to be 4 of the big R of y, which is going to be root 4 minus y plus 3. That's all squared minus that 3 squared dy. Go ahead and type that in your calculator. I already did that, and hopefully everything's accurate. If it's not, feel free to leave a comment. Or you know what? Just feel free to leave a comment anyway. There's a good chance I'll respond. 0.6637. I'll just truncate. Okay? And all we got left here is one more problem. Okay, so we're going to find the volume of the solid formed by revolving the region bounded by the graphs of the given equations and the indicated axis. So here we go. First one's going to be a parabola. I'm looking at this. I'm guessing this is going to be all in quadrant 1. I'm pretty sure that's going to be accurate there. So this is all in quadrant 1. So I'm just going to just draw quadrant 1. 1/4 x squared. I'm going to do that in. I'm going to do that in red. So it's going to hit at 0, 0. When x is 1, that doesn't really give me anything good. What about when x is 2? At 2, I'll go up 1. When x is 4, I go 4, 4. I feel like that's enough points. And I can kind of go from there. And then I'll do the next one in pink. Y squared equals 4x. This is the same thing, by the way, as y equals, if I square root the 4 and the x, I'll get 2 root x. So, we're actually going to intersect at 0, 0, and 4, 4. So, looks something like this. Okay, there's my object. I'll shade that in. I'll shade that in gray. Okay, and then my axis of rotation here is at 6. 1, 2, 3, 4, 5, 6. Don't forget to put the little rotation. And there we go. This one's a little tougher to kind of think of how this one rotates. I think this kind of sort of looks like the object that I started with in a little bit when at the beginning of the video when I was rotating it. It'll kind of look like that. But first is first, I have to figure out where these things intersect at. I can just tell because I graphed it. But what you would do here to see where these intersect, you would just set the y equations equal to each other. So you do 1/4 x squared equals 2 root x. And you would just go from there to solve these. I'll just tell you right now, this happens at x equals 0 and x equals 4. Those are where those are equal. So let's go ahead and solve. So let's go ahead and do green. We always, so this is I'm going to do my radius now. Always start from the axis of rotation. And you're going to go from the top here, and I'm going to keep going until I get to the furthest part away from the axis of rotation, which is going to be the red graph. So my r of x is equal to big minus little. Big is going to be the axis of rotation, which is going to be 6, minus little. Little is red, which we said is 1/4 x squared. And then for orange, start from the axis of rotation, and then we're going to end at pink. So little r of y is going to be 6 minus 2 root x. Okay, a lot of people think that, hey, the big radius should be the pink. The pink is taller than the red. I don't care about that. I care about where it is with respect to the axis of rotation. The red will always be further away from the axis of rotation when we rotate this around, and the pink will always be closer. So that's why pink is the smaller radius, and the red there is the larger radius. So from here, I'm pretty much good to go. I have everything set up. V equals pi. I have the bounds from 0 to 4. I showed that earlier. Big radius squared minus little radius. A lot of times questions like these are just setup only, but we'll go ahead and get this answer. As long as I typed everything in correctly and I did this ahead of time, I'm going to get 140.743 units cubed. We don't include the units cubed. And do not forget to like and subscribe to see more videos like this.